Okay, day 4. We're going to talk more about rational functions, something about a hole, and finding the coordinates of those holes. They'll still have a vertical asymptote. X and Y intercepts should not be too bad. And we'll sketch a graph, and if it has holes, we'll account for them. So, rational function. The denominator gives us a clue as to whether we have a vertical asymptote or this new thing, a hole. If a factor reduces out of the numerator and denominator, I'm not going to say cancel, but that's kind of what happens, then there is a hole. To find the hole, the x and y coordinates of the hole, we'll replace the x of the hole into the reduced function, which won't have a 0 in the denominator. If nothing reduces out, we have our old friend, the vertical asymptote. So the denominator is 0, or the denominator is what we look at. We factor it, and to make it 0, x could be 3 or negative 3. Nothing reduced out, and so the vertical asymptotes are x equals 3 and x equals negative 3. But here, we factor the denominator and something reduces out. And so we have this left, and the part that reduced out, x still can't be negative 3. But if we place that negative 3 into the remaining reduced fraction, I get negative 1/6 when I plugged in negative 3. And that's where the hole is. When x is negative 3, I plug into the remaining fraction and I get negative 1/6. So we have a vertical asymptote and we have a hole. Set this guy to 0, and it's not going to happen because if I square something, it's positive. Add 9, it's more positive. It's never going to be 0. No vertical asymptote, no hole. A review for locating intercepts. If we want to find the x-intercept, y is 0. And if we want to find the y-intercept, x is 0. So I take this, it factors. To find the x-intercept, y is 0. So I set the fraction equal to 0. When a fraction is 0, just the top is 0. And I get negative 4/5 and negative 10. When x is 0, when y is 0, I get the x-intercepts. The y-intercept is easier because when the y-intercept x is 0, I plug in 0 for x, and I just do the arithmetic. 40 over 16 reduces to 5 over 2. X is 0 for the y-intercept. Here we factor, and something reduces out. And so here's what we have left. To find the x-intercept, y is 0. For the y to be 0, the top has to be 0. After we have the hole, well, I have 1 over x plus 4. For that to be 0, the top has to be 0. Never going to happen, so we don't have an x-intercept. To find the y-intercept, I plug in 0 for x, and if I plug in 0 for x, I'm left with negative 8 over negative 32, which is 1/4. So I have a y-intercept and no x-intercept. For C, I factor again. Don't forget, the first thing you look for when you factor is a common factor. And the denominator factors as well. Nothing reduces out, so there's not going to be a hole, not that they asked for it. To find the x-intercept, y is 0, and for the function to be fraction to be 0, the top has to be 0. So for x, and I have two x-intercepts. To find the y-intercept, we plug in 0 for x, and we see that we have 0 for negative 100, which is 0. And that's our y-intercept. So here, if you don't look at everything, you're going to make a mistake. You might look at this and go, oh, to find the vertical asymptote, set the denominator equal to 0. Well, before you do that, factor the top, factor the numerator. And lo and behold, something reduces out. Okay? And so for the moment, we're just going to graph y equals x plus 2. That's a line with a y-intercept of 2 and a slope of 1. But for this portion, x also can't be 2. When something reduces out, that's where we have a hole, when x is 2. To find the y-coordinate of the hole, we plug the 2 into the remaining fraction, or in this case, not fraction, but remaining expression, and we get 4. So at 2, 4, we put a hole in. And so it's a line, but there's a gap at x equals 2. So there's a gap in the domain, and there's a gap in the range.